Hello, good morning, good afternoon, good evening to you, wherever it is you are joining us from. Once again, my name is Dr. Sandra Powers, the founder of 3 AI related businesses. I'm an AI strategist, an AI consultant, and as I just mentioned a few seconds ago, also an AI entrepreneur. My life revolves around AI now. Artificial intelligence has become my finding place, my home away from home. I am a 20-year plus veteran of development teams, projects, portfolios, and assignments. I've worked nationally and internationally for B2B, B2C, government to commerce, web to commerce, individual basis, as the case may be. So I come before you also as the founder of the Artificial Intelligence University. And that is one of our AI related businesses, and it's specifically dedicated to the business of all things AI, teaching AI, onboarding people onto AI, helping people understand how they can port onto it. Myself and faculty partners giving people the opportunity to understand the domain behind the programming, the domain behind the tooling, the domain behind the various algorithms, the domains behind the technology of the now. The technology of the now, the greatest disruptive technology of this generation is artificial intelligence. And it is why it makes for very good business to be able to know about it, to embrace it. It makes for very good business to be curious about it. And it also behoves anybody that hopes to get into the technology space or work in the technology space from this point here on should really be in the business of embracing all things AI, finding out what AI means, and then choosing from the various different strands of AI what works for them. I started this session a few videos ago, and I had started initially with helping people understand exactly what AI is, the very many different layers that it has. It's like an onion, you see. And from the mind map in front of us, you can see that there are different layers to AI. There's the machine learning aspect of it. There's the NLP aspect of it. There's speech, expert systems, planning, scheduling, and optimization element. There's the robotics and robotic process automation element of it. And then, of course, there is the visioning of it. You know, the first industrial revolution came about as a result of mechanization, steam, and water power. The second industrial revolution came about as a result of mass production and electricity. The third industrial revolution came about as a result of electronic and IT systems and automations. In the fourth industrial revolution, cyber physical systems became the order of the day and still the order of now. In this particular version of the Industrial Revolution, we see artificial intelligence come into its own. and the Internet of Things, networks, big data, mega data, accelerated technologies, bleeding edge technologies, augmented reality, cloud computing, mobile device usage, Internet of Things platform, location detection technologies, advanced human machine interfaces, and human machine interactions, seamless interactions between the human and the machines, and authentication and fraud detection, 3D printing, smart sensors, big data analytics, and also multi-level customer interaction and customer profiling. That is what describes this particular era of the fourth generation of industrial revolution. So we have digitization and integration of value chains. We have digital business models and customers access. We have digitization of product and service offerings. Artificial intelligence is in the middle of all of that. It's extremely related to all aspects of life and industry, domain, and sector. In the diagram that you have in front of you, you can see that it applies to agriculture as well as translation services, whereby we go from text to audio or audio to text. Artificial intelligence applies in healthcare, medical and media imaging, medical record management and data mining, surgical robots, build and use of bionic machines to help those who need rehabilitation, the use of AI for rehabilitation equipment, intelligent pharmacy, drug design, drug technology design, and such like. Manufacturing, which tends to be the most stable, the most normalized, and the least affected by technology tends to be, but it has also been caught up in the disruptive technologies and the impact of IT and digital, and more to the point, AI. AI applies in digital marketing and e-commerce initiatives. The need to be able to understand customer DNA to the nth degree, the need to be able to shape suitable journeys for different customer segments and types, the need to be able to make the customers seamlessly journey into optimized customer experiences, building immersive customer experiences. All of that is facilitated by AI. In the domestic robot scene, smart home automation, Alexa, Google Nest, the Home Hub, such like, have become de rigueur. And more and more and more, especially with the Internet of Things, the interconnectedness of systems inside the homes, outside the homes. Inside has become outside and outside has become inside. So symbiotically existing is the world of the external vis-a-vis the world of the internal. Artificial intelligence makes that possible. Also in finance, financial services, everything from banking to loan procurement to finance and credit rating to insurance services, be it long-tail business, short-tail business, be it any different line of business of insurance you can think of, commercial, policy administration, first notification of loss, be it commercial insurance, be it London markets insurance. I've just finished an assignment recently for Acrisure Insurance in the city, and monolith and a beast as the City of London Corporation may be, the organizations that sit within the city are very quickly, especially on the back of COVID-19 and the forced and governments forcing people to work from home. It It has really meant that AI has also come to stay and has infiltrated operations in the city. So everything from your banking to finance to venture capitalists to asset management, acquisition, lending, borrowing, controlling financial services, fraud initiatives, they have all become very enabled and disrupted largely as well by artificial intelligence. So a few sessions ago, I put the case forward for artificial intelligence, explained what that domain was. It's important you understand that artificial intelligence is not just a glib mention. Artificial intelligence is a huge umbrella. Artificial intelligence, although a lot it's known about it, there is still a lot that is unknown. So we have known knowns, we have known unknowns, and then scary, very scary, but there is also the concept of the unknown unknowns. And that is where we begin to get into super machine intelligence, where neural networks will come into their own and machines truly begin to mimic and become like people, thinking like people, talking like people, understanding like people, working even better than people. We will get to, well, the intention is that that's the end of the continuum, and that's what we're striving for. But applications of AI are many and varied. Everything's from gaming to robotics to e-commerce to agriculture to entertainment to social media, automotive services, surveillance, education, such like. Now, a few sessions ago as well, what I also did was took people through the construction of a use case diagram. And I was able to do that. I don't know why this is not showing on screen, but I can always show you what I did. I was able to come up with this use case diagram. Now, it was important for me because in my journeys to various contracts and assignments, I've seen various representations of artificial intelligence, but I've never really seen, given my 20 years, an analyst is only as good as his or her tool set. And what the benefit of 20 years have done for me is I'm very quickly able to come in to an organization as part of the diagnostics that I run, and the need to be able to very quickly understand where it is that the business wants to go to. I construct artifacts, particularly I love the use case diagram. Use case diagram is not an archaeological remain. It's not an ancient style of delivery. It continues to be relevant. It's about 30 plus years old, and it's part of the UML tool set. It's used to construct interaction diagrams, explains who is using the system, helps us understand the boundaries of the system, helps us understand the various goals of the system, and also helps us understand the secondary actors, systems that are impacted by the realization of each use case. And so what I did in the first video of this series was that I was able to construct the use case diagram based on what I knew. And what we're doing on a video by video basis is building on that. So we've gone from this 100,000 feet picture to now a 50,000 feet picture, whereby we are now able to start investigating the various use cases that sat in that previously high level use case. This is the next level of detail. I call this the 50,000 feet use case diagram. You see, if we go back to, just to quickly remind ourselves, the original use case diagram had 7 elements at a very, very high level. This is cloud level picture. And at this level, it's just important that, you are trying to communicate something on a single sheet of paper. Well, we to start breaking down the information behind this domain in each of the use case ellipse. Each of this use case ellipse, if we start breaking the information down, we will come up with something deliverables that will amount to over 100,000 pages of text. But we haven't got that time. Imagine the scenario: you are dealing with C-level colleagues who haven't got time, who want you to come into the organization, and who for 6 months, 3 months, 4 months, 5 months, 6 months, 12 months want to onboard you on an initiative that will see you translate a part of the artificial intelligence domain, illuminate it more so that a certain aspect of technology can be implemented for the good of the business, that operational excellence is achieved, that costs are lowered, that the value chain is made slicker. So whenever you are onboarded into an organization, you are onboarded as a solution provider, as a solution bringer. It is not up to the organization to train you necessarily, especially as a contractor, in skills such as use case modeling and use case construction and use case design. No, it's up to you, the analyst, it's up to you, the AI engineer, it's up to you, the design specialist, it's up to you, product owner, digital business analyst, to be able to be clear, using your own tool set to quickly construct this. You can be in a meeting and construct a use case diagram. You can construct a use case diagram during your lunch hour. You can spend the whole week constructing several use cases, and because every time you meet with the stakeholders to discuss, to agree, more light is shed on the system and the boundary and the interplay of relationship between human and system. You change an aspect of it. So basically, these use cases are also another way of seeing what we had seen before: the landscape diagram, the mind map diagram. Use case diagrams are also an extra tool that is worth having in the repertoire of an analyst. Now, this is the computer vision domain use case diagram. We can see the computer vision user. This is what we put together in the last video. For those of you who wish for the videos of the sessions that I have had with you, by all means, send me an email and I will send you links. We have a channel on Telegram that we communicate on, that I would like you to come on board. We have internship sessions where we have all hands on deck, getting your hands dirty on about 60 different AI projects, getting the source codes, getting the PowerPoint presentations, getting access to the back end, being involved in all hands on deck sessions with mentors and instructors who have had ample years of immersion in the artificial intelligence domain. So we put this together. This particular diagram explains how the computer vision domain, which was just a single ellipse in this use case diagram, you can see it there. This here says process computer vision. This little diagram, or what you may call a small part of this diagram, is what we eventually blew up. This is the 100,000 feet picture, but this right here is a 50,000 feet picture, whereby we took that use case ellipse and then we detailed it. This is not all the detail that there is, but this is the next level of detail. You see, The business of analysis is one whereby you have to model the system. I take an onion approach. There are several layers of diagramming, of model construction that helps you paint a picture of the problem space. And we did that for computer vision. It's my intention to carry on doing this for each of those other use case areas. And for computer vision, this is a non-exhaustive list of applications. And by all means, if you do wish for this PowerPoint presentation, do let me know and I can send it over to you. My focus today is NLP, Natural Language Processing. NLP, Natural Language Processing. Were I to go back to the origin of this, I would go back to the mind map. And you can see that natural language processing, NLP, was the second strand in the AI mind map. This very second strand breaks out to translation, classification, clustering, and information extracting. Whoa, let me stop there. We need to take a few steps back. What is natural language processing? What is it? What exactly is it? Is it part of AI? Is it a different part of AI? Is it something else like AI? What is NLP? What is natural language processing? Ladies and gentlemen, you have it in front of you. Natural language processing is a field of artificial intelligence. So it's a branch of artificial intelligence that gives machines. Remember, artificial intelligence is wanting to give machines the ability to be able to mimic humans in tasks. So natural language processing, a branch of artificial intelligence, a field of artificial intelligence, gives the machines the ability to read, to understand, and derive meaning from human language. What do I mean? Basically, when humans speak and write in English, in Spanish, in French, in Arabic, in Chinese, but a computer's native language is known as machine code or machine language. In the same way that human beings speak, machines also speak. But the problem is that machine speak is largely incomprehensible to most people. Machine language is ones and zeros. Machine language is not like human language. So the work at hand is that the NLP system first of all, it has to understand the language that the person is speaking. It then has to interpret that language in the context of the speakers. After interpreting it, after understanding it, after interpreting it, then the machine has to translate what it has interpreted of that human text or human speech. It has to translate it into a machine speak. It has to translate it into something that the machine can use. Natural language processing is a big area. One of the most challenging and revolutionary things artificial intelligence can do is to speak, is to write, is to listen, and then to understand human language. Oh boy, very challenging and incredibly revolutionary. So natural language processing is a form of artificial intelligence that extracts the meaning. It extracts the meaning from the human language to then make decisions based on that information. So listen to this. The workflow is this. Number one, understand the language. Number two, machine interpret the language. Number three, extract meaning from the language, translate the language. And then number 4, make decisions based on that information. So there's a lot of things at play here. You can begin to see that the remit of natural language processing is limitless. Most of us have virtual assistants in the form of Amazon Echo, or we use Google Home in our everyday lives. Whether you know it or not, these are all different types of of natural language processing used in one's daily life. Every day as humans, we exchange countless words with other humans. We get all kinds of things accomplished. But communication is much more than words. There is context, there is body language, there is intonation, there is idiom, there is sarcasm in the language, there is the intention of the words that are communicated. You can begin to see the range of complexity, that the machine has to deal with. This is really going to make you respect Alexa more. This is really going to make you respect Siri more. When you ask Siri for directions, or when you send a text, natural language processing enables that functionality. Natural language processing allows it to happen, makes it happen. Natural language processing is a very important area of artificial intelligence. As at 2018, the natural language processing market was estimated at 8.61 billion. Well, you know what? By 2026, that figure has been conservatively estimated. And apparently, the powers that be, Fortune Business Insights, is looking at a figure of 80.68 billion. 80.68 billion by 2026. That's a huge jump. The world has sat up. The world has now understood that there is big business in natural language processing. Natural language processing is artificial intelligence that helps computers understand, interpret, and manipulate human language. So a lot of us have used Facebook, and sometimes we may even, or even Twitter, or YouTube, we may share news articles that we got from whatever source has released that. And then very immediately it is flagged up as fake news. What is happening? How is that able to happen? That's because the websites, Facebook, Google, YouTube, they all have artificial intelligence, or rather natural language processing algorithms built into the back end that is quickly able to understand and interpret and question the veracity of news articles and then suppress that news story. Now you can begin to understand why fake news has become a well-used phrase in this age and time. So natural language processing is artificial intelligence, helps computers understand, interpret, and manipulate human language. It's key. Without NLP, without natural language processing, Google will not be Google. Google will not be Google. It means users cannot come to the machine, enter a phrase or an idea into a search box, and then instantly see personalized recommendations. Oh yes, natural language processing is what made companies like Google who they are. Without natural language processing, it's very easy to lose customers. You can imagine as consumers, we describe things in an almost infinite number of ways. But e-commerce enterprises don't. There's a definitive list of descriptions for products and services. So when a shopper types something into the search box on Google, how is it possible for the retailer's website to understand? What facilitates the taxonomy, the product description at the back end? What is powering it to enable the retailer's website understand and then recommend? How is it you go to Google, you may mistype something, but as soon as you click the send button, you are having before your face various recommendations from people such as Amazon, eBay, and as the case may be, for products that you entered the name into the machine, but you entered it wrong. So already there's a mismatch between what a shopper is searching for and what a retailer's website will understand. And this impacts search quality, and this has repercussions. I'm just giving you examples of why it is artificial intelligence, natural language processing is key. So basically, companies increasingly learn about consumer needs and attitudes, preferences, and frustrations online. What is helping companies? What is helping them paint a picture of the customer sentiment? How is it that they can classify customer emotions based on reading a text from a customer? The fact is, there are copious amounts of text. There are copious amounts of information. There's a ton of unstructured data. What that thing that you are typing in to search on the screen, that feedback you are giving, that review that you are giving, that tracking, that cookie information, all of that email, that free form text, all the posts that we push out on Facebook, on Instagram, and various other types of social media, the product reviews is big text, and it's messy, and there's copious amounts of it. And this data does not fit into predefined data models that machines will understand. So machines need help. So NLP, natural language processing, is the help that is used to translate unstructured data, mounds and tons of unsifted data, mine it using algorithms, transforming that spontaneous communication into something that the computer can understand, into something that the computer can translate, into something that, it doesn't matter whether the jumble is whether it's a jumble of sentences, whether it's a mountain of colloquialisms, whether it's jargon and lingo which we see every day. Natural language processing will help you make sense of the blob of data, of the blob of information. And so this is where we are. We have come to the point where we need